In the last lesson, we took a look at the quadratic relation y is equal to ax squared plus k, and that dealt with looking at vertical shifts and also the change in shape of a parabola. But now we're going to take a look at extending that form of the parabola a little bit further, and we're going to take a look at the relation y is equal to a times, in brackets, x minus h all squared. And again, a and h are still numbers. They represent either fractions or decimals or whole numbers or integers, positive, negative numbers, whatever. Okay, but they're just numbers. That's all they mean. And so what happens to the graph when we change the value of h? Well, if we graph y is equal to x squared, that is, again, our parent form of the parabola. Okay, and so if we graph our parent form of the parabola, we know that its origin is at 0, 0. Okay, and then using our step pattern, it goes over 1, up 1, over 2, up 4, over 3, up 9. Okay, and so shifts up. However, if we change this, if we have this equation, and again, what we can see here is that there is a positive 1 there, so the a value hasn't changed. We're not changing the shape of the parabola. But instead of having y is equal to x squared, we have y is equal to, in brackets, x minus 4 all squared. Then what happens now? Well, if you have y is equal to x minus 4 all squared, you actually shift the parabola 4 units to the right. Okay, and because the shape hasn't changed, we still use our same over-up pattern. Okay, so over 2 from the vertex, up 4, over 3 from the vertex, up 9. So, they actually intersect at one point. Okay, and then finally, if we take a look at the equation y is equal to x minus 7 squared, what happens now? Well, if we do this, it actually shifts the parabola, again, from the original position by 7 units to the right. And still the over-up pattern, the step pattern, remains the same. Okay, so 3, 9. So if the h value in the equation looks like it's negative, okay, it's actually moving to the right. Okay, so therefore, if h is a positive number, it moves to the right. And why do I say positive number? Well, because in the form of the parabola, this is actually the same as saying y is equal to a times x minus 1 times h, whatever h happens to be, all squared. Okay, so if h is a positive number, then negative 1 times a positive number makes a negative number. If h is a negative number, then it becomes positive. Okay, so if in the equation here, the h value is actually equal to positive 4, and here the equation, the h value is actually equal to positive 7. So it's the opposite of what it shows up in the equation. So this is probably the most challenging thing for people to remember, is that the value of h switches signs. Okay, so if it says that it's negative 4 in the equation, the actual value of h is positive. If it says that it's positive, the actual value of h is negative. Okay, and so when the h value is a positive number, it shifts the parabola to the right. So if we extend this a little further, what happens when the h value ends up being a negative number? So again, if we graph the parent form of the parabola, we see that we have a vertex that starts at 0, 0, or at the origin. And then using our step pattern, it ends up looking like this. Okay, but now, if we have y is equal to x plus 2 squared, all squared, then what ends up happening is that this parabola, the green parabola, is actually going to shift itself horizontally 2 units to the left. So in this instance, the step pattern remains the same, okay, but now it's going to shift itself 2 units to the left. Okay? And here the h value is actually -2. Okay? Because -1 times -2 equals +2, and that's what ends up happening inside the bracket. So if we look at this example, where we've got y is equal to x plus 7 all squared, where the h value is actually -7, then again, it is shifted horizontally 7 units, okay, but it still goes over 1, up 1, over 2, up 4, over 3, up 9. So again, the h value determines the horizontal shift, okay, and so that's probably the key to remembering it, is that h stands for horizontal shift. So if we consolidate that information, then what we can tell is that in y is equal to a x minus h all squared, the value of h determines the horizontal position, okay, the left and right position. The horizontal position, okay, left and right. And so if h is greater than 1, i.e. it's positive, then it gets shifted to the right of the y-axis. If, however, the h value is negative, then it's shifted to the left of the y-axis. Again, the most challenging thing is the fact that these equations are equivalent. Okay, and these equations basically mean that what the h value appears to be in the equation is actually the opposite. So that's the hardest part for people to remember. If in the equation the h value looks like it's supposed to be positive, it's actually negative. And if it looks like it's supposed to be negative, it's actually positive. And that's the toughest thing for people to remember.